So, we've gotten our hands on something that feels like it was beamed back from the future. It's a guide to the next great leap in technology, Agentic AI. And trust me, this isn't just about making chatbots a little bit smarter. It's about building AI that can actually do things in the world.
So what's the big deal here? Well, think about the AI you use today. It's an amazing assistant, right? You ask for a trip itinerary and boom, it gives you a perfect plan. But you still have to go book the flights, reserve the hotel, buy the tickets. Agentic AI, well, it takes that next huge step. It doesn't just write the plan for you, it actually goes out and executes it, all on its own.
According to this handbook, what makes an AI truly agentic really boils down to three key things. First, autonomy. It decides for itself what to do next. Second, tool use. It can actually use software and APIs to take actions just like a person would. And third, multi-step reasoning. It can make a plan, see what happens, and then adjust its plan on the fly. It's really the difference between a calculator and a full-blown accountant.
Okay, but how does this stuff actually work? Let's pop the hood for a second and look at the fundamental building block of every single agent. This is literally the heartbeat of the machine. It's all built around this deceptively simple but incredibly powerful loop called the ReAct pattern. First, the agent reasons. It thinks through what its next logical move should be. Then it acts. It calls a tool, maybe searches a database. And finally, it observes the result of that action. Did the search work? Did it get an error? That observation feeds right back into the next round of reasoning, and the loop just keeps going. Reason, act, observe. Simple, but it's everything. So, a core engine is great, but it's not enough, right? To be useful, an agent needs senses and hands. It needs a way to remember what it's learned and a way to actually interact with the world around it. And that is where memory and tools come into the picture.
You know, an agent's memory isn't just one thing. It actually has four different types. You've got in-context memory. That's its short-term scratch pad. Then there's external long-term memory, like a huge database it can search. There's also episodic memory, where it remembers what worked and what failed on previous attempts. And finally, skill memory, where it stores knowledge of how to do things, kind of like a chef remembering a recipe.
And this slide just brilliantly shows how you can assemble all these components into different patterns. A single agent? Great for simple, focused tasks. But for something more complex, you might use an orchestrator that delegates jobs to specialist agents. Or for massive parallel tasks, you could unleash a whole swarm of agents. The key takeaway here, and it's a big one, is to always start simple. You only add complexity when you absolutely have to.
And hey, this isn't just theory. The handbook points to a case study from Anthropic. Get this, they found their AI agents could automate 44% of the engineering tasks that the engineers themselves didn't want to do. Just think about that for a second. Freeing up nearly half their time to focus on the more creative, enjoyable work, that is the real-world impact we're talking about. Okay, so you've got all these agents, you've got all these tools. How do you get them all to talk to each other without creating absolute chaos? Well, you need a common language. You need a universal network for AI.
The handbook has the perfect analogy for this, and I love it. USB-C for AI. It's this idea of one standard plug that just lets any agent connect to any tool. This standard is called the Model Context Protocol, or MCP, and it solves the massive headache of having to build custom connectors for every single tool and data source out there.
And this network really has two key parts. You have MCP, which is for connecting an agent to its tools and data, but then you also have A to A, the agent-to-agent protocol, and that's how different agents can find each other and collaborate on tasks. They work together. MCP is for the tools, and A to A is for teamwork. So, we have the engine, we've got the memory, the tools, the network, but getting all of this to work reliably in the real world, that requires a completely new skill set. It's a discipline that goes way, way beyond just writing good prompts.
The handbook calls this new discipline context engineering, and the difference here is absolutely crucial. See, prompt engineering is about finding the perfect way to phrase a single request, but context engineering is about managing the agent's entire worldview, its context over time. The key question isn't, how do I ask this? It's, what information does this agent need to see at this exact moment to make the right call? And getting this wrong is a huge deal. The handbook outlines these common failures. You've got context poisoning, where bad information gets in and just makes everything worse. There's distraction, where old, irrelevant history confuses the agent. Imagine it trying to book a new flight but getting hung up on details from a trip you looked at last week. There's also collapse, where summaries lose critical details. And bloat, where just throwing too much information at the agent actually makes it dumber. But the payoff for getting context engineering right is massive. I mean, look at this chart. A 20-step task could burn through 800,000 tokens if you just naively keep stuffing history into the context. But with an optimization technique called KV caching, which is like giving the AI a much smarter short-term memory, that cost plummets to around 40,000 tokens. That's a 95% reduction in cost and latency. It's a game changer. This all brings us to the most important question, really. With all of this incredible autonomous power, how do we build agents that are safe, that are reliable, and that we can actually trust to do real work in the real world? A case study from Google's CTO office in the handbook puts it perfectly. Evaluation became architecture. What does that mean? It means testing isn't something you just tack on at the end anymore. It has to be a core, continuous part of the agent's design. The system you use to measure performance and trust is just as important as the agent itself. The handbook shares a simple but really profound safety principle called the irreversibility rule. Before you let an agent do something you can't take back, like deleting a database or sending a company-wide email, you just have to ask yourself, what's the worst that could happen if this goes wrong? And if the answer is pretty serious, you must add a mandatory human confirmation step. It's really that simple. So the most crucial thing is knowing what to avoid. This table summarizes some of the key anti-patterns to watch out for. Don't over-engineer. Always start simple, because complexity is the enemy. Don't just stuff the context window. Curate it, because more info is not always better info. Don't change the tools mid-task. It kills performance. And finally, don't just evaluate the final answer. You have to evaluate the path the agent took to get there. So this handbook from the future, it gives us the blueprint for building these incredible, world-changing systems. But it leaves us with one final, really provocative question. As we start building these agents to manage more and more of our world, who manages the agents?